How does an escalator haul 140 people up an incline as steep as Mount Fuji? What gives a handheld leaf blower the power to whip up hurricane-force winds? And how does a tape measure cram 5 meters of precision steel into your pocket? To answer these mysteries, we dive deep inside these and other extraordinary machines to reveal the secrets of how things work. The escalator, one of the hardest working machines around. At one of London's busiest metro stations, it shifts up to 13,000 people an hour all year round. But getting caught in such a powerful machine can cause serious injury. So how does it lift more than 100 people at a time, smoothly and safely? More than 10,000 moving parts work together. A tough steel cage on the outside takes the weight of 30 armored tanks every hour. 157 aluminium steps travel so far in their lifetime, they could go to the moon and back, yet always stay level. A heavy-duty electric motor can lift the weight of 2 elephants. This is a multi-million-dollar workhorse, powerful and built to last. When full of people, this escalator weighs 54 tons, the same as 18 SUVs. So it's got to be incredibly tough. The key to its strength lies in the way engineers build its frame. At this 15,000 square meter factory in Illinois, the frame starts life as 11 centimeter thick steel beams. Workers cut these to precise lengths, up to 1,500 per escalator. Crack welders then turn this pile of metal into a huge reinforced cage called a truss.
This unit's 104 foot long. You gotta have good, strong welds.
Butch makes the panels that form the truss sides and base.
I love welding. I started here in January of 1973. Been welding 37 years. These diagonal pieces actually keep it solid. That's why you see so many of them. Yeah, we make them as tough as possible here.
But being tough isn't enough. Workers must fit these side panels together to form a rigid cage with supreme precision. Otherwise, the stairs could jam. So they hoist the panels into a huge metal guide frame.
That feels real good right there. This yellow fixture, it has a series of plates along one side that are all set in line straight. And when we put a side on up against these stops, we'll put big C-clamps on like that. That's the key to getting a true straight escalator.
The end result? A giant steel cage, accurate to within a few millimeters all the way down, and strong enough to lift 140 passengers in a single ride. So how does it pull such a huge load? Hidden under the top of the escalator, a giant electric motor works round the clock. Inside, 2.5 kilometers of copper wire and a huge electric magnet spin a drive shaft 700 times a minute. This powers a set of cogs that gears down the revs and locks into a 6 centimeter thick chain. The massive drivetrain pulls the steps upwards at exactly the same speed, no matter what the load. The steps are part of a hugely complex mechanism. Any big bumps or vibrations could knock passengers over, and it's a long way down. The secret to making sure that doesn't happen lies in the way workers put them together, by hand.
We just take pride in what we do. You know, I build it as if it was mine.
Tab fits the drive chain and steps on some of the biggest escalators in America.
The escalator itself will have a 77-foot rise, so that's almost 8 stories. The unit is 188 feet long. The steps are attached to the chain with step pins put together correctly. With the dimensions set properly, the escalator runs smoother. Clear!
The steps themselves also play a big part in making sure passengers don't feel any bumps in their ride.
This escalator, once it's completed and installed, will have 269 steps. A lot of steps. Each step has 2 sets of wheels. It's our trail wheel. It rides on a piece of flat track that keeps everything in line so it can rotate around the escalator virtually rub-free, noise-free, and safe.
This flat inner track solves one of the fundamental problems of escalator design, keeping the steps and the people on them level all the way up. So how do steps form a rigid staircase on the slope, then collapse into a flat platform so people can get off? The 2 sets of toughened plastic wheels on each step run on completely different tracks. The front set hooks up to the drive chains moving the escalator. The rear set locks onto the inner track. As the steps rise, the tracks draw close together and tilt the steps to form a staircase. At the other end, the tracks move apart again, so the steps make a platform and you can get off. But the combination of moving metal with lots of power has a flip side. Getting caught and dragged into an escalator can cause serious injury. So the first rule of escalator design is safety.
It hurt you. We don't want that. We want everybody to be safe getting on and off our escalators we build.
Sean installs one of the most important safety features, the comb plate.
It's a key safety feature of anything getting sucked underneath. Yeah, but everything needs to be square.
The comb plate protects one of the most dangerous parts of an escalator, where you step off at the end. Here, a moving step meets a static landing plate. If this trapped clothes or shoes, it would be disastrous. But this almost never happens thanks to the way the comb plate meshes with the deep grooves in the escalator steps.
Well, the steps got the grooves in it so it could line up with the comb plate segments. So any type of debris that's in a crack, they're gonna ride up on top of the comb.
It's a simple system that keeps passengers safe. And it's the reason all escalators have grooved steps. Once everything's installed, it's time for a full-speed test.
At this point, we are running it as a final checkout, making sure there's no noises, no pops.
Shannon makes sure every escalator runs as smooth as butter.
We have to make it as smooth as possible. You've been here long enough, you'll feel that something's not right, and we'll correct this, make it as quiet as possible before it even goes out the door. And if you're riding on an escalator, you don't want to hear noises. You definitely don't want to hear noises.
The steps are running smoothly, so this escalator's ready to ship. Across Europe, over 75,000 escalators transport millions of passengers every single day. We walk all over them, but these unsung heroes work long hours, pulling tough loads to keep our subways, malls, and cities moving. The leaf blower. How does a machine you can easily hold in one hand blow air at twice the speed of a hurricane? Under a tough polymer casing, 230 parts work together. a super light aluminium alloy engine with more power per kilo than a dirt bike, a fan wheel with toughened blades that suck in 12,000 liters of air a minute and ram it through an aerodynamically shaped nozzle to create the perfect storm in the palm of your hand. Generating winds this strong is a formidable engineering challenge. In this 36-acre factory, it all starts with the way engineers build the fan wheel. This tough part is actually made of plastic.
These are the plastic pellets that create the actual fan wheel. It obviously has to endure a very violent condition, and at 10,000 RPMs, you don't want shards of plastic launching around.
Marco knows pretty much all there is to know about making things out of plastic. If the fan wheel shattered when spinning, shards could fly off at serious speed. To make sure this doesn't happen, Marco uses a top-secret blend of plastics for strength. Moisture in the air can weaken the part, so he runs the pellets through huge dryers, then pumps them to plastic injection machines. These heat the material to melting point, over 200 degrees, then inject it into a metal mold.
This is the fan wheel as it is in the mold. The plastic is injected on this end of the runner.
A robotic arm picks up the scrap, while the finished fan wheel rides a conveyor to where it's checked for flaws.
The toughest piece of plastic we produce.
This looks nothing like a normal fan blade. So how does a small disc of plastic whip air into a mini tornado? The fan at the heart of a leaf blower is smaller than a dinner plate. So how does it generate hurricane-force winds? With the engine at full blast, the fan wheel spins nearly as fast as a jet engine. Every second, its S-shaped fins scoop up 200 liters of air. They squeeze it sideways into a snail-shaped casing and down a narrowing nozzle, thrusting it out of the end at 260 kilometers an hour. The leaf blower's nozzle doesn't just direct the fast-moving air, it also actually increases its speed. The secret to how it does this is the unusual way engineers construct it, using the power of air itself.
Each one of these machines runs approximately 2,500 parts per shift, which would be 5,000 pieces per day.
Tim runs machines that inflate the nozzle like a hot plastic balloon. A molten tube drips down between two specially cooled metal molds. When they clamp together, a hollow metal pin blows air into the tube of hot plastic. The air forces the plastic out into the shape of the mold.
Once the mold opens up, the mold pin retracts, strips the part off of the blow pin, and drops it on the conveyor belt for the operator.
Workers then trim the nozzle to size. The end result is a tough tube with a perfectly smooth interior that narrows towards the tip. As the air blasts down the nozzle, it's forced into a smaller and smaller space. This actually makes the air move 10% faster. Moving air at these speeds takes a powerful engine, but building a motor that is light enough to hold in one hand is a big engineering challenge. A ruggedized aluminum alloy casing cuts down the weight. At the heart of the machine, a single piston the size of a chess piece pumps like crazy. It fires on every turn, twice as fast as the engine on your car. This tiny powerhouse weighs as much as a carton of milk, but packs more punch per kilo than a monster truck. The quest to reduce weight doesn't end with the engine. Every single component inside this machine must be as light as possible.
Being a handheld blower, we're always thinking about lightweight.
Brian runs the assembly line that turns boxes of components into a finished machine.
The inner fan housing is your main support, kind of like the component that everything else would be attached to.
In a car, the engine is bolted to a metal frame for strength. In the leaf blower, it's bolted to a housing made of lightweight plastic to save weight. When they come off the production line, these units are ready to blow. The end result is a tough, powerful, and lightweight machine. A tiny hurricane you can hold in your hand. The humble tape measure is cleverer than you might think. How does it squeeze 5 meters of precision-engineered steel in a package that fits in your pocket? Under a toughened plastic case, 26 components work together. A tightly wound metal blade with super accurate markings. A rocker that can lock the blade without breaking it. And a tightly wound spring that retracts the blade in a fraction of a second. It is 5 meters of pure precision that fits in the palm of your hand. The key to an accurate tape measure is the way workers make its metal blade. In this UK factory, the blade starts life as a long strip of hardened steel. Workers wind it onto special cartwheels that weigh 130 kilos each and roll them to a custom-built painting machine. This paints the steel bright yellow to make the black markings easier to read. Next step, a digital printer marks out the numbers.
This prints all size blades from 2 meters to 100 meters.
Anita makes sure the printed markings on every tape are accurate. It's a big responsibility.
If it's out, then whatever you're building won't be straight. So you'll end up with sort of a shelf like that, or a house, or whatever you're building, it'll be all wonky.
The painted tape runs through a series of rollers up to precision print heads less than 1/4 millimeter wide.
So we have 3 black heads and 3 red heads, and it spray jets very, very finely the image, whatever you're printing, onto the blade.
The end result, markings accurate to the width of a human hair. But it's no good having a super accurate tape that you can't carry around with you. So how do you neatly coil up 5 meters of steel at the touch of a button? The end of the measuring blade hooks onto a soft metal strip that's almost as long as the blade itself. As it coils around a central hub, it turns into a powerful spring that winds more tightly as the blade slides out. But release the lock, and the spring recoils to retract the blade in the blink of an eye. Getting the tension of the spring right is crucial. Too little and the tape won't retract. Too strong and it could hurt the person using it. So workers tailor-make the spring to the specific length and weight of each blade.
This machine makes the springs, which goes in the tape measure, which gives it the power. There's so many different components going into one tape measure that it's not as easy as it looks.
John's made tape measures for 27 years. The steel runs around a narrow metal rod at the heart of this machine.
And I run some through, chop it, put the auto on, and away you go.
This produces a curl, just like running ribbon over a ruler.
That's the first thing that goes into the tape measure, is a spring.
Workers mount the spring into a special machine that winds it onto a central pin inside the tape measure's body. Final assemblers install the rest of the internal components before the quality controller attaches the blade. But the tape measure has one final trick up its sleeve. Designers make the tip so it can move backwards and forwards. When hooked over something, the tip extends so the blade only goes up to the edge of what you're trying to measure. But to measure an inside edge, the tip retracts so the end of the tape butts right up to whatever it's measuring. We take this mini machine for granted, but millions of handymen and women across the world couldn't do without the breathtaking precision that fits in your pocket.